Hello, and this is video 12 of Computer Programming 1, Introduction to Computer Programming with Java. We're picking up on video 11. We're going to continue to explore strings. Where we left off is we wrote the program and we have the fetchVehicle method. And this is reaching into the file called chardata.txt. And then the scanner gets a reference to that file and prompts for the first line of data. Now, you wonder why it's called next line. We could do this repeatedly. We could get one line at a time. To do that, we'd have to understand about iteration and looping, which won't come until later in the quarter. Nonetheless, we're able to read in the first line from our chardata.txt, which is this. A character which represents what kind of car, maybe a car or a truck or something else. And then a comma, and then a number that represents an odometer reading, and then a comma, and then a number that represents miles per gallon, and then a comma, and a number that represents gallons of gas. Our job now is to take this string, determine how we can split it up based on these commas, and then how we can take those values and pass them into setter methods to set attributes of a vehicle object. So first, how do we take a string and chop it up? We'll have to remember what a substring is. Remember that a substring says, give me everything from one position inclusive to another position exclusive. Okay, we give it two numbers, where we'd like to start, and the position after where we'd like to end. Remember back to our spreadsheet where we have Ohio as a swing state, and we start counting the first character at 0, and then if we say 11, 14, we mean include 11, 12, and the 13, and stop right before 14. It's kind of goofy, but that's how we do it. Now, to make use of that, we're going to have to know where these commas are. And what we can do for that is we can use a method of class string called indexOf. Okay? And if we take 142, we'll be fine. If we take a look at the indexOf method, we'll see it's overloaded. It's an overloaded method. Okay? In other words, we can give it a single string, or we can give it a string in a position where it should start looking. If we just give it a string, it's going to start from position 0. If we give it a string and a number, it's going to start looking at that number. This is going to be very important because we're going to want to know the location of the first comma, and then we're going to want to know the location of the second comma and the third comma. And the only way we can know the location of the second comma is if we say start immediately after the position of the first comma. So we're going to need to use both of those overloaded methods. And let's take a look and see. Okay, so the entire string is stored in this variable called entire line. What I'm going to do now is I'm going to find the position of the commas. This is what we'll call a comma-separated value file, where our values are separated by commas. What that lets us do is it lets us use a variable width of each of these values. So odometer might be 10, might be 100, might be 1,000, 10,000, 100,000, a million. We're not going to tell it how big it has to be. We just say, when that number's finished, put in a comma. So comma-separated values, generally, the values can be variable length. The values we're putting in the file can be variable length. In mainframe days, we typically used a different kind of file system, which was a fixed width field, where there was no separator. Instead, we would say something like, the car type will be the first position, and then the odometer will be the next 7 characters. And then the miles per gallon will be the next 2 characters, and then the gallons of gas will be the next 4 characters, something like that. So a mainframe equivalent of this might look like this. C 0120000 020 120. That's not as easy to read, is it? Because we have to know then, okay, the car type is the first position, miles on the odometer are the next 6 positions, and then the miles per gallon are the next 3 positions, and then the gallons of gas are the next 3 positions after that, and the final character of gallons of gas is a decimal. So it's harder to read, obviously. The other thing is that because the width of the fields are fixed, you tended to have to go with the highest value. So if an odometer reading could be 1 million, then you had to reserve 7 characters for the odometer, whether you used it or not. So it wasn't very efficient. But nonetheless, like I said, in the 80s and the 90s, and even into the decade that followed, the aughts, as we say, it was very common as programmers to have to read mainframe files, do something with them, and then create a file that can be read by a mainframe. I spent quite a bit of my career doing that. So we'll stick with our comma separated value. Again, that's a bit more intuitive, a bit easier to read. And I go back to vehicle DAO, and we're going to find where the commas are. So the comma positions are going to be defined in an int. An int is a whole number data type, which makes sense because 0, 1, 2, 3, 4, 5, 6, these are all whole numbers, right? So I'm going to say int first comma equals entire line dot index of, let me go back and do that again, just that part. And you see it gives me some helpful hints here. We see there are actually 4 overloaded versions of this method. Okay, one takes a string, another takes a character in the form of an int, another takes a string and an int, another takes a character in the form of, anyway. You see there are 4 different versions we can call. We just want to call the first one here. I want to say, give me the very first comma. That's easy. It's going to start at position 0 and look for that very first comma. The second comma is a bit more challenging because we have to say, look for the comma after the first comma. But again, because it's comma separated values, each of these pieces of data can be any length, really, within reason. Each of these pieces of data can be any length. So what we have to do is be a little bit tricky and say int second comma equals entire line dot index of, once again we'll say comma, but the from index, take a look at that. The from index is what is important. We want to say first comma plus 1. So look for a comma, but start looking 1 position after the first comma. Third comma, same deal. Entire line dot index of, we'll give it the comma character, and then we're going to say second comma plus 1. There we go. Okay. Now that we have the comma positions, look for the strings between them. Okay, we're not worried about the type of car. Well, we can handle that later. But we do know that between the first and the second comma, we're going to have the odometer reading. So I'm going to say string str odometer equals entire line dot substring. Remember the way a substring works. Start at the beginning index inclusive, end at the end index exclusive. Don't count the end index. So this gets a little bit tricky. We have to say first comma plus 1 because it's going to include whatever character's at that position, and we don't want to include the comma. So start right after the first comma, end with the second comma. Remember, it's not going to include that end index. It's going to go right before it and then stop. So that will give us our odometer. Okay, now convert the odometer from a string to an int. If I wish to convert something from a string to an int, I'll say int odometer equals integer dot parse int. That parse int method means accept a string, return an int, str odometer. Okay. Now let's do the same thing. Well, we'll go ahead and call the setter method. Pass this odometer value to our vehicle stored in variable my vehicle. Okay, my vehicle dot set odometer, int odometer. And there we go. Now, we just need to repeat the same thing for our miles per gallon and our gallons of gas. So, get the miles per gallon from the string. Okay, string str miles per gallon equals entire line. This time we want everything between the second comma and the third. So I'm going to say second comma plus 1, because remember we're going to go 1 after the second comma because it's going to include the character at the first position. Third comma, and remember the last position is exclusive. Better spell it right. Third comma. Okay, and then we'll say, oh, I'm sorry, entire line dot substring. Okay, now we'll say int miles per gallon equals integer dot parse int str miles per gallon. Terminate with a semicolon. Okay, my vehicle dot set miles per gallon, int miles per gallon. Okay, and now we'll say get the gallons of gas value. Okay, again, repeat the same thing. The only difference here is we use a double instead of an int. String, oh, one other difference too. String str gallons of gas equals entire line dot substring. Now, one thing that's nice, if we want everything that ends a string, there's an overloaded method of substring. If we only give it one number, it will give us everything from that position until the end of the string. So what I can do here is say third comma plus 1. And that will give me everything from the third comma until the end of the string. A little shortcut. Okay, double dBl gallons of gas equals double dot parse double. If we want double precision, in other words, if we wish to have a floating point number, we'll use the double dot parse double, and then we'll pass in the string we wish to convert, str gallons of gas. Terminate with a semicolon. My vehicle dot set gallons of gas, dBl gallons of gas. Now, at this point, we have read in all the data we wish to read from the file. What I'm going to do now is I'm going to print out the state of the vehicle, run the vehicle 100 miles, and then print the state of the vehicle again. So I'll say string pre-state equals my vehicle dot toString. Okay, system out print line pre-state. Okay, and plus pre-state. Okay, so I'll put a message to this effect. Get the state of the vehicle before running it. Okay. And then we'll do string post state, just same thing. My vehicle dot toString, system out print line, post state, okay, plus post state. Easy as that. We need to run the vehicle. So in between, let's see, I'll put a note. Print the state of the vehicle after running. Okay. Now we'll say run the vehicle 100 miles. My vehicle dot go 100. Note what's nice here is that I'm using a different user interface, right? I'm pulling data out of a text file, but the toString method that I developed before and the go method I developed before for vehicle, I get to reuse. Notice in this entire example, I never had to change the vehicle class at all. I'm reusing all the setter methods, reusing the toString, reusing the go, so on and so forth. So it's very easy if we separate our concerns. It's very easy to have one place where we have our data and our logic, and then maybe two places where we're feeding data into that and getting data back out of it. So it makes reuse much, much easier. Seems simple on a little program like this, but when you get into heavy industrial strength software, that can make a lot of difference. Okay, at this point I'm finished with what I want to do here, so I'm going to step into the debugger. And again, if you have not explored the debugger yet on your own project, the sooner you do it, the sooner you try it and get frustrated, give up and try again, the better off you're going to be, because the less time you're going to have to spend doing homework. The debugger will make things much, much simpler. Okay, so I'm going to right click and I'm going to choose debug, and then I'll walk us through this one line at a time. When I choose debug, the Pepto-Bismol colored line is going to change to mint green, and then it's going to give me an opportunity to step through this line by line and see what every line is doing. Okay, so I choose debug. Okay, the first thing it's going to do is call the constructor on the vehicle object. I can press F7 and we see it's initializing the state of vehicle so that all the attributes have the value 0. Of course, we know we're going to change this in a moment as soon as we read from the text file. We're back to our vehicle DAO class again, the one we've been working on in the last couple of lectures. We access the file cardata.txt, which has our car data in a flat file. Okay, we pass that file to a scanner. The scanner can read a line from the file. Now, we get the index of our first comma, second comma, and third comma. And this is where it's very helpful to scroll up and look at our variables. First comma, position 1, second comma, position 7, third comma, position 10. Let's take a look at our car data and make sure that makes sense. Remember, we start counting with 0. 0, 1, there's our first comma. 2, 3, 4, 5, 6, 7, there's our second comma. 8, 9, 10, and there's our third comma. Sure enough, the first comma is character number 1, second comma is character number 7, and the third comma is character number 10. With this information, we can now interrogate this string and get the data out between these commas. So I go back to vehicle DAO, and let's keep running. Well, let me scroll this down if I may. There we go. And let's keep running. Now, string str odometer. This is a great case to use the debugger. I want to make sure I did my math right. Okay, I want to make sure I'm calling the substring method properly. So I choose F8, and I immediately go to the debugger to make sure. Well, the other thing I can do, I can just hover my mouse over that variable, and you see there it has str odometer equals 12,000. Just to double check, I can look in the variables tab. There we go. Str odometer equals 12,000. Very, very handy. Okay, parse that to an int. I choose F8. Now change the state of my vehicle. Once again, I scroll up. Look at my vehicle. It's initialized with everything set to 0, but as soon as I go here and choose F8, we see it changes odometer to 12,000, and that's the value we got out of our text file. Now miles per gallon, we'll do the same thing. Let's make sure that miles per gallon looks accurate. I'm going to need to scroll up here a bit more. There we go, miles per gallon 20, the value from our text file. Okay. Let's change the state of our vehicle, and I'll expand on my vehicle, and we see that miles per gallon is now 20 for my vehicle. Okay, let's get the gallons of gas value, which is 12. We see the gallons of gas changes down in the debugger window. Now we're going to gather the previous state of the vehicle and print that out, so I click on output. And we see gallons of gas 12, odometer 12,000, subject to check yes. Now we move the vehicle 100 miles. Let me F7 into here, and when I F7, you'll notice that the vehicle DAO tab will no longer be lit up. Instead, the vehicle tab will light up. F7, and here we go. Here's our vehicle tab lit up. We're going to do the exact same math we've been doing all along in vehicle because we're using the same class that we used when we had our user interactive driver as opposed to this text file. F8, again, doing the same math, F8, 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 and we're back to vehicle DAO. Now we're going to get our state after populating the vehicle, and we're going to print that out. And we see, sure enough, gallons of gas 12,000 on the odometer. We run 100 miles. Gallons of gas changes to 7. Odometer changes to 12,100. Works as expected. And we're all done. I'll go back and just to prove that we have a flexible and dynamic system, I'll change the vehicle type to car, all uppercase. I'll change the odometer to 120,000. Miles per gallon, we'll leave it 20. Gallons of gas, I'll make a really weird, funny number. Okay, I'll save this. I'm not going to debug this time. I'll go ahead and just run. And we'll see that it's going to read this data in as needed. As a matter of fact, for the odometer, just to make sure we know how many characters, I'll make it 123,456 miles. Okay, gallons of gas is at 12,000 and change, and so on and so forth. So I save. Vehicle DAO, right-click and choose Run. Okay, and there we go. Starting gallons of gas, 12,023,44522, whatever. Starting odometer, 123,456. After running, gallons of gas, 7. Odometer reading, 123,556. So we see, even as we change the length of the data, our program can adapt. We've taken an in-depth look at two methods of class string, and that is indexOf and substring. Sorry, I had a sudden brain cramp. IndexOf and substring are the two we looked at. There are several others that are very important. The opposite of indexOf is charAt. IndexOf, we provide a letter or a character or a string, and it will tell us where it found that. So let me rephrase that. indexOf starts with a string. We provide to it a character or another string. indexOf will tell us where it found that character or string within the original string. If it can't find it, if it cannot find it, it will return a -1. Many times we'll use that to test, to say, does this string contain another string? If it equals -1, then it does not. So indexOf, accept a string, return an int. charAt, C-H-A-R-A-T, does the opposite. With that, you give it a number, and it tells you which character is at that position in a string. So charAt, give it a number, it will tell you what character it found at that position within a string. Length tells you, again, a lot of these are on the slides for this class. Length tells you the number of characters in a string. 2 uppercase will return a new string that's equal to the original string except all letters uppercased. 2 lowercase will return a new string equal to the original string but with all characters lowercased. Replace will replace one character with another. So several handy methods. There's a method called dot equals, which will compare 2 strings and tell you if they're the same, or dot equals ignore case will tell you if 2 strings are the same but not case sensitive. So those are the options that we have. There's one other option, and that is, this sure seemed like a lot of work, didn't it? Well, incidentally, Java does give us another option. There is something called split. If I say entire line dot split, I can give this a delimiter, which in this case is a comma. It will take this line and split it up into its constituent parts. That would save us from all this effort we did here. Now, why didn't I do that in the first case? Number one, split is a newer method. We didn't have it before. So you might find legacy code that doesn't use it. Number two, Doing it the old-fashioned way gives us an excellent hands-on case of using indexOf and substring. Number 3, split returns what we call an array. An array is a collection of multiple pieces of data of the same type. We don't know what an array is yet, so we would have to know that first. The truth is, arrays will take us right into our very next subject, which is iteration and looping. So arrays will take us into that. But at this point, we don't know what an array is yet. To declare an array, I use the data type string and then open and close square brackets and then say all data equals entire line dot split. What this is going to do is take that line, split it based on that delimiter, cut it up into multiple strings, and then put each of those strings into this variable called all data. Okay, at that point we could go in here and do the same kind of work we did down here where we got our miles per gallon and our odometer. Not too hard. Let's go ahead and run this in the debugger right now and see what we get. Okay, actually I'm going to move this breakpoint since we've already excuse me. Sorry, I had a sneeze there, and so I paused the recording just in time. I'm going to move this breakpoint down because we've already seen this part. I'm going to move it right down here to our split method. Right click and choose debug, and we're going to see what we get out of the split. Okay, oh, I forgot I have another breakpoint set. Okay, let me F8 through this breakpoint, and here we go. Okay, now it's going to take the line of data split based on the comma. F8. Let's go down in the debugger and see what we have. All data, take a look at that, very nicely divvied up for us. Car, odometer, miles per gallon, gallons of gas. Just one method split it up very nicely, and it gave them numbers starting with 0. The first string is in number 0, second string in 1, third string in 2, fourth string in 3. Okay, given that, I'm going to finish the debugger session, and I'm going to show you an alternate way to do this. str miles, let's see, we'll do it this, well, str miles per gallon equals all data, and let's give it the, let's see, miles per gallon was, oh, I'm off, I should do odometer first, shouldn't I? Miles per gallon was the second string. Okay, let me grab odometer up here. Okay, string, well, I'll tell you what I'll do. I'm going to do it a little different way. String str odometer equals all data, position 1. Now I can't double declare, so I'm going to comment out the old way to do it. I'm going to comment that out temporarily, but I want to post this on Blackboard, so when I post this on Blackboard, I'm going to go back to the first way we did it. Hope that makes sense. Okay, so I'm going to comment out the substring method, and I'm going to replace that with string str gallons of gas equals all data 3. I'm going to replace it with our new method, just using split. If we use split, we don't have to worry about any of this. We don't have to worry about substring or anything. Let me go ahead and debug one more time. Okay, split the line. We're going to go in the debugger, make sure it's split properly. Oop, there we go. Position 0 is car, or string 0 is car. String 1 is the odometer. String 2 is miles per gallon. String 3 is gallons of gas. Sure enough, it's split properly. And now I'm going to F8 through this. We're going to see it will properly parse from a string to an int. Set that in our vehicle. Parse our gallons of gas. Okay. Print the prior state. Move the vehicle 100 miles. And print the after state. And if I go back and look on the output, we're going to see that doing it the new way gave us the exact same result as the old way, and we didn't have to mess around with our indexOf or our substring. So we're coming up on 30 minutes, and that wraps up what I wanted to say about strings. So lots of things going on here. Remember to fill out quiz question suggestions. I believe I said quiz question suggestions 5 and 6 for this lesson. So think of good questions here. Think of charAt, indexOf, substring. Think of some good tests you would do with the substring. Put them on quiz question suggestions, and we'll go from there. The next subject we're going to talk about is decisions with if tests. After that, we're going to talk about iteration and looping. After that, we'll catch up on some other topics and do a general review. Perhaps we'll talk about colors or exceptions. And that wraps us up for the quarter. So about 3 major topics yet to go this quarter. Uh, the next topic we're going to cover, the next 2 topics will help you on programming assignment number 3. At this point, you have everything you need for programming assignment number 2. Thank you.